Today we're going to look at systems of linear inequalities, and we're going to graph a system. We're going to look to see if we can find a solution, and then we're going to write some systems of linear inequalities from a graph. So previously you learned kind of how to graph an inequality, and we'll be doing that today. So for example 1, I've got two inequalities. It's a system of linear inequalities. And I want to look to see if a particular solution or ordered pair is a solution to that system. So I'll be looking at these two inequalities and the 0.35. So really what you're going to do is you're going to just substitute those in for x and y and see if it's true. So if I look at the first inequality, it's y less than 2x. So I would have 5 less than or equal to 2 times 3. And 5 is less than 6, so that is true. On the second one, I would do the same thing. Y greater than or equal to x plus 1. So y is 5, and x would be 3, so 3 plus 1. And 5 is greater than or equal to 4, and that is also true. So yes, that is a solution to the system. Okay, so that's really all we're really doing, kind of similar to like we did it with equalities. So let's look at these two, just do them quick. The first one is y less than 5. 5, right away off the bat, 5 is not less than 5. So 1 is going to be not a solution, just by the very first one. So sometimes you don't have to go too far. So that first equation is false because 5 is not less than 5. Okay, so then we go to number 2. I'm going to put 5 in for y greater than or equal to 3 times negative 1 plus 8. So 5 greater than or equal to negative 3 plus 8. 5 greater than or equal to 5. That's true. The second equation, I'm going to have 5 greater than negative 3 minus 1, and that's going to be true also. So 2 is a 2, the solution is true, 1 is false. Okay. Now we're going to be looking at graphing, and I'm going to apologize. I don't have my pen today, so these graphs may not look that great, but so let's look at A. So I'm going to graph the line y less than or equal to 3. So y is going to always be 3. I have the equal sign there, so it's going to be a solid line at 3. And like we did today, you talked about where do I shade. So this is less than 3, so it's going to be everything underneath that line. And then the second line, I've got a y-intercept of 2. Roughly, trying to make that. And then a slope of 1, so up 1 over 1. So my line's going to kind of look something like that. And this is everything greater than, so that it's going to be greater, so it's going to be above that red. And it'll stop at this line. So my solution is right here. That's where my solution lies. So basically you look to see, hey, is it less or greater? So if it's greater, it's going to be above the line. If it's less than, it's going to be below the line. And then the two lines will constrain itself. Okay. If you look at B, the first thing I want to do is solve for y. What I'm going to end up doing is both of them are going to have a slope of -2 because I'm going to move the 2x over on both of them. So what do we know about that? Well, they're going to be basically, they're going to have the same slope, different y-intercept. So let's plot the first one in black. So a y-intercept of -1, and then a slope of -2, so down 2 over 1. So my first line is going to be right there. And I'm not going to do the above and below thing yet. I'm just going to plot the other line. So we'll do that one in red. Y-intercept of 3. It's going to have that same slope, -2. All right, so where's the solution? Okay, so if I look at the first equation, it's y less than. So it's going to be everything below the black line. So everything below that. And then the second one, it's y greater than, so it's everything above the red. So actually, is there anywhere where the two mesh? And that is the question. The answer would be no. So there is no solution. They need to mesh like they did in A. The red and the black were in that same area. Okay, so let's look at a couple more. So we got two lines. You may have to solve them for y. The first equation is y greater than or equal to -x plus 4. So it's got a y-intercept of 4. And then a slope of -1. So down 1 over 1. So it's going to look something like that. I'm not looking for complete accuracy, just an idea where your line is. Let's go ahead and shade this one. So it's y greater than or equal. What I didn't do in those first two is show you that, hey, when is it a solid or dotted line? So this first one, it's definitely solid because it's greater than or equal. And so it's going to be above this line. Okay, that's where the black lies, where the solution lies for that one. So if I plot this other one, slope is going to be -x because I'm going to move the x to the other side. Y-intercept is at 0 and a -1 slope. So down 1 over 1, roughly like that. They actually both have the same slope. Again, just like in that other one. So they're going to be parallel lines. And then it's y less than or equal to solid line. So it's less, so it's below the line. So this is another one where there's actually no solution. Okay, because they never mesh. I don't have the cross section in both of them that mesh. Okay, so now if I look at number 5, plot the first line, I've got a y-intercept of -3. Okay, so that's right there. And then a slope of 2, so up 2 over 1. This is going to be a dotted line because it doesn't have the equal sign. So that's the only hiccup there when I didn't do those other ones like that. All right. Second line has a y-intercept of 1 and a slope of 1/2. So up 1 over 2. And this will be a solid line. It's going to be something like that. All right. So then we got to decide where's the shading go. So in the first one, the y greater than 2x minus 3, that's the black line. The solution is above the black. Okay. And in the second one, it's also above the red. So it's going to be above the red. Let's plot that. So everything above the red. All right. So really, where is my solution then? Well, it's anywhere where the two are in the same thing. So basically, all this, and I stop right there. So I don't go any farther. That's wherever so the red and the black. So I'm going to make this solid so you kind of see. So that's going to cut off the green going that way, kind of like that. And that's what you're looking for when you graph these. You're looking to see if the two actually, the crosshatch is in the same part, and that's where your solution is. And we can go over this when I get back a little bit more too. All right. So what we're going to do here in example 3, we've already got it graphed. You can see where the blue shading is. That's where my solution is. So really, I just want to look at the 2 lines, and I'm going to write an equation for each line. So let's do the easy one first, the horizontal line. So this guy right here, this horizontal line, and it intercepts at -2. So y is always -2, and it's a solid line, and the shading is above. So I'm going to say y, and above means greater. It's solid, so it has the equal, and then the intercept, so it's y greater than or equal to -2. Now the other line, we'll do that one in red. That's this guy right here. Its y-intercept is 0, and its slope is, if I look at the line, you go up 1 and over 1, so it's a +1 slope. And the shading is below, and so I'm going to go y, it's below, so it's less than. It's dotted, so it doesn't have the equal sign. It has a slope of 1, so it's just x, 1x, and then the y-intercept was 0, so it's just that. That's your 2 equations. That's your system. That's really all you're doing. Okay, so let's practice that a couple times. So here we go. Got 2 more lines here. Let's do vertical line first, this guy. So this is going to be an x because it's vertical. X is always 1, 2, -3. So x is negative something, and the shading is to the left, which would make that excuse me, I read that wrong. This is a +3 because I'm going from 0, so I'm going 1, 2, 3. So it's at 3. Shading is below, so it's less than. It's solid, so it includes that equal sign. So it's x less than or equal to 3. Okay, so let's do the dotted line. We'll do that one in red. So that's this guy right here. The y-intercept is -1, so let's put that there. The slope looks like it is up to over 3, so 2/3. So I'm going to have y. The shading is above, so it's going to be greater. It's a dotted line, so it won't include the equal sign. And we said 2/3 x. That's that equation. Okay. So let's do a little bit more practice. Let's do these 2. So in 6, I have 2 horizontal lines. The dotted one is at 1. The solid is at -3. Okay, so those will both be y's because it's a horizontal. Let's do that one in red. So the black one is at -1. The shading is below. It's going to be less than. It's dotted, so it won't include the equal sign, and it's at 1. The second line the shading is above it. So that would be greater. It's a solid line, so it includes that, and it is -3. Okay. So switch it to number 7. Let's do the horizontal line, vertical line. Excuse me, first. That's at 3. So X is, the shading is to the left of that vertical line. So it's going to be less than. It's dotted, so it won't include the equal sign, and it's at 3. Okay, so that's my vertical line. So let's do this other dotted line. Y-intercept is at 2. The slope is down 1 over 1, so it's a -1 slope. So I'm going to have Y. The shading is below, right here. So it's below that. So it's going to be less than. It's dotted, so it won't include the equal sign. We already said it has a -1 slope, so -x, and then a y-intercept of 2. And there you go. That's how you write 2 equations from a graph. That's how you write a system. So that's pretty much it. We'll have a short worksheet that'll get handed out here that you guys can kind of work on and practice. And when I get back, I'll review this with you also. All right. Everybody have a great day.